And last time we were factoring, we did greatest common factor, factor by grouping, and then we did factoring trinomials where a is equal to 1. Well, today we are now going to factor trinomials where a is greater than 1. So, and we're going to use a method called the educated guess and test method. There is another method I'll show as well. It's a longer process, but it may be more suited for you guys. But again, we'll do educated guess and test, and then I'll show you the other one. Okay, so whenever we're given this type of trinomial, the first step is to list all factors of the leading coefficient a, and then list all factors of the constant c. And then just like last time, whatever the signs of your trinomial are, that's going to tell us how to set up our parentheses. And then based on all the factors we have from the leading coefficient and the constant, we're going to mix and match them until we get it right. Okay, we'll be factoring masters by the end of today, hopefully. So let's start with number 1. Okay, using the guess and test method. So once again, if we're going to use the educated guess and test method, the first thing we do is we take all the factors of the leading coefficient. We find all the factors of the leading coefficient. That makes 6. 1 and 6, 2 and 3. Those are the factors of 6 in order. And then all the factors of 10. 1 and 10, 2 and 5. Okay. And then next, what we have is setting up the signs of our parentheses. Here we have plus, plus, my favorite, because this means your parentheses are going to be plus and plus. All right. So now when we set up our parentheses, I'm going to have something plus a number and something plus a number. So the factors of the first term, right? The factors of the leading coefficient will go into the first positions in our binomials. So I'll put blue here. The constants, the factors of the constant, will go into the second position of my binomials. Okay, and now to possibly save us some time, this trick works probably, I'm going to say this trick works 95% of the time. So we have to know what factors to choose. And this trick is normally the bottom factors of the leading coefficient and the bottom factors of the constant are always the correct choices. But like I said, it only works 95% of the time. So if this doesn't work, then we're going to have to figure other things out. Okay, so I'm picking 2 and 3, which means I'm going to put 2x here and 3x there, because 2x times 3x makes 6x squared. And then I'm going to put 2 and 5 in here in the last positions, but you have to be smart about how you place these numbers. So I'm going to put 5 here, and I'm going to put 2 here. And again, this is all trial and error. If you put 2 here and 5 there first, that's all good. We're still going to have to FOIL and check our work. And if that doesn't work, all we have to do is flip the numbers around. So I'm putting 5 there and 2 there. And now what we're going to do is check our work to make sure we have the right answer. So we're going to FOIL this, and 2x times 3x, 6x squared, 2x times 2, 4x, 5 times 3x, 15x, and 5 times 2, we get 10. Combine your like terms, and we get 6x squared plus 19x plus 10. Does that look like the original problem?
Yes, sir.
Yes.
So that means we have factored it correctly, and we have factored it correctly on the first try, which is amazing, right? So you're not always going to get it on the first try. The way we usually do factoring without these little tricks I introduce is that when you're given the factors above, let me just erase those, you would normally go, all right, I'll start with 1 and 6, and I'll multiply it by 1 and 10. If that doesn't work, I'll say 1 and 6, and I'll multiply it by, oh, there should be a 2 here. Hang on, I erased that. So I'll say 1 and 6 times 1 and 10. If that doesn't work, then I'll say 1 and 6 and 2 and 5. Now let's say none of those combinations worked. So then you would move on to the next list of factors. You would say 2 and 3, multiply it by the factors of 1 and 10. If that doesn't work, then you go 2 and 3 and multiply by the factors of 2 and 5. That's how the educated guess and test method works. And the reason it's called the educated guess and test is because it's going to get you faster at multiplying numbers, adding numbers, to where when you start factoring these, you look at them and you're like, hey, 6 is 2 and 3, 10 is 2 and 5. If I put those together, will I get this problem? Will I factor this correctly? And you start multiplying faster in your head. This is why it's called educated guess and test. You guess until you get it right. And then we can provide tricks. As I just said, since I don't want to spend over an hour on this type of factoring, I'm like, hey, let's introduce this trick. And it works, like I said, about 95% of the time. The last factors of your leading coefficient and your constant will always work 95% of the time. But you must list your factors in order for this to make sense. Okay, so we get the answer correct on the first try. This is just a check. It's always good to check your work. I'm not saying you'll always have to do it, but it's always good to check. Okay. Now, so that was educated guess and test method. The next method I'm going to show you is called the AC method. And since you're business majors, it's okay to use the AC method. If you were in my regular college algebra, my pre-cal or my Cal 1, I would kick you out of my class for using AC method. But the way AC method works is, well, remember that what we're given are trinomials that are quadratic in form. So the leading coefficient is A and the constant is C. So with the AC method, we take, I'll put AC method. We take whatever A is and multiply it by C. So in this case, our A value is 6 and our C value is 10. So that's what we're going to do here. We're going to say 6 times 10. All right. And then we know that's going to give me 60. And now we must list all the factors of 60. Oh boy. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and then 6 and 10. 7, no, 8, no, 9, no, 10. Okay. And now with this AC method, we ask ourselves, out of this huge list of factors, which of these factors can add up to 19? Can add or subtract to 19? And what are those going to be?
15 and 4. Oh,
15. 15 and 4 can make 19, right? So if I wrote that out, you would have this as 4x plus 15x would give you 19x. Okay, so this is what we're going to do for the AC method now. We found the factors that could make 19. So I'm going to rewrite this as, oops. I'll go over here to the right, 6x squared. So we'll start with 6x squared plus, I'll write the original problem again, 6x squared plus 19x plus 10. But now using the AC method, we are going to take that 19 and split it into the two factors we just found. 19 is going to become 4x plus 15x plus 10. We haven't done anything wrong. We just said, hey, 19, you're going to be 4x and 15x, which is still 19. And what the AC method does is it turns the trinomial into a 4-term polynomial, which we know that can be factored by what method? How do you factor a 4-term polynomial?
Grouping.
Grouping. Good. And we see that from 6x squared plus 4x, I can take out a 2x, which would leave me with 3x plus 2. And then from 15x plus 10, I can take out a 5, which would leave me with 3x plus 2. And since these look the same, you can factor that out, and we'll get 3x plus 2 times 2x plus 5, and there you have it. We get the same answer, but about 30 minutes later. But it is fail-safe. So choose the method you like. I'm going to teach the rest of these notes using the guess and test method, though, because that's just a lot faster. And if I keep doing this lesson by AC method, we wouldn't finish this lesson until probably tomorrow. But any questions on that one?
No, sir.
Okay. Let's keep moving. One moment. No, it doesn't want to load. Okay. Let's keep going. All right. So more factoring, and we're going to do this by guess and test. So once again, here is 12. This the factors of 12, 1 and 12, 2 and 6, 3 and 4. Lucky for us, here's 2. The only factors are 1 and 2. And now we have plus minus, which means that I'll get something plus a number and something minus a number. And remember, blue is for factors of the leading coefficient. Second spot is for factors of the constant. Okay, so let's see which factors are going to get us what we need. And I could do 3 and 2 and 6. No. Maybe that'll work. So let's go ahead and try our trick out. Let's say 3 and 4. And the only factors here are 1 and 2. So I'm going to say 3x and 4x. And then I'm going to put in here 2 and 1. Let's see how that works out for us. Let's go ahead and FOIL to check our work. And I'll get 12x squared minus 3x plus 8x minus 2. Combine like terms. And I'll get 12x squared plus 5x minus 2. Oh my goodness. Does that look like the same problem above?
Yes.
Yes. So we get the answer immediately. Not bad. Okay. Any questions on that one? Okay. Let's keep going then. Guess and test is the way to go, guys. All right. Again, 6, 1 and 6, 2 and 3, 4, 1 and 4, 2 and 2. Okay. Let's see. And then look at our signs. Minus plus means minus minus. So I'm going to have something minus a number, something minus a number. And now we can try our trick out, but let's see if it'll work. This is all about being educated guessing tests. So if my trick doesn't work out, it's back to the drawing board. So I'll put 2x here, 3x there, and then I'll have a 2 and a 2 here. Okay. And then if we FOIL, I would have 6x squared minus 4x minus 6x plus 4. This will give me 6x squared, and I know it's supposed to be w. I'm just, x's are better, minus 10x plus 4. Does that look like the original problem above?
No.
No. So guess what? Our trick doesn't work. Like I said, only works 95% of the time. So this means 2, 3 with 2 and 2 are not going to work. So now we should try 2, 3, and what other factors?
1, 4.
1, 4. Let's try 2, 3, and 1, 4. And I'll put a 1 here, and I'll put a 4 there. Let's see what happens. Check our work again. 6x squared minus 8x minus 3x plus 4. We get 6x squared minus 11x plus 4. Hey, does that look like the one above?
Yes.
Yes, we got it. So it's just one big trial and error, y'all. And change those to W's if you want. You get the point, though. Okay. Let's keep going. All right. Next. 3z squared plus 2z minus 8. List our factors. Hey, lucky for us, only factors of 3 are 1 and 3. And then factors of 8, 1 and 8, 2 and 4. Plus minus means exactly that. Our setup will be plus a number, minus a number. And since we're starting with 1 and 3, we only have 1 and 3. That makes it easy. I'll put 1x there, and I'll put 3x there. And now we have to be smart. We have to make an educated guess. Do you guys want to try 1 and 8, or do you want to try 2 and 4?
Two and 4.
Let's go 2 and 4. Okay. Let's see if this works out for us. I'll put a 2 there. Oops, needs to be red. I'll put a 2 there. I'll put a 4 there. Let's see what we get. Let's check. 3x squared minus 4x. Sorry, I'm not going with the same variable, but you guys get it, right? I should have just made these all x's. Plus 6x minus 8. Combine like terms. 3x squared plus 2x minus 8. Does this look like the one above?
Yes, sir.
Above.
Look at that. We got it. Just x's instead of z's. All right, not bad. All right, 5. Let's go ahead and rearrange this because we see we have 7p minus 15 plus 2p squared. Everything's out of order, so I'm just going to rewrite it as 2p squared plus 7p minus 15. So I just put everything from highest power to lowest power to constant. And now we list the factors of 2, 1 and 2. List the factors of 15, 1 and 15, 3 and 5. Okay. And we have minus plus, which means minus minus. So we'll get something minus a number, something minus a number. And again, lucky for us, we only have 2 factors here of the leading coefficient. So I can go ahead and put those in already. And I'll follow the correct variable this time. I'll have 1p and 2p. And now, if we want, now we need to make an educated guess. Would you like to go with 1 and 15, or would you like to go with 3 and 5?
Three and 5.
3 and 5? Okay, let's see. I'll put 3 there. I'll put 5 there. Let's check our work. 2p squared minus 5p minus 6p plus 15. Uh-oh. 2p squared minus 11p plus 15. Does this look like the one above?
Nope.
No, right? So, actually, whoops, what did I do wrong? 2p squared plus 7p minus 15. Oh, I had it backwards.
I had to twist something, didn't we?
I was being dyslexic, guys. Since it's plus minus, that means one of these has to be plus and the other has to be minus.
There we go.
I was just
There
about
we
to
go.
ask why both of them are negative.
There you go. But let's see what that does. So if that's a plus, I still get 2p squared. I still get negative 5p, but now I get positive 6p, and that would just leave me with negative 1p, which still doesn't look like the above, right? So there are some quick fixes. Since 3 and 5 didn't work this way, one of the quick fixes is to switch the numbers around. So we're going to swap the numbers, the number placement. So now this 3, we're going to put the, we're going to put the 5 there instead. And where the 5 is, we're going to put the 3. We can just do a quick number swap like that. That's one of the easiest fixes. You can swap the numbers or you can flip the signs. So let's try it again. All we did was a number flip. So p times 2p, p squared minus 3p plus 10p minus 15. And I get 2p squared plus 7p minus 15. Does that look like the above?
Yep.
We got it. Perfect. And now it's factored. Okay. Any questions on that one? So 1 and 2 and 3 and 5 worked. Okay. All right. Next, 2t plus 7t squared plus 6t cubed. Again, this is out of order. So I'm just going to rewrite it again from highest power first to lowest. So 6t cubed plus 7t squared plus 2t. And now, once again, we can only factor it using the guessing test if the highest power is squared. Right now, the highest power is cubed. Do you see a greatest common factor that we can take out?
1t.
1t, because you got t cubed, t squared, and t. So we can take 1t out, and this would leave me with 6t squared plus 7t plus 2. And now the inside trinomial is of the form that we can use, because now the highest power is a square, is a 2. Okay. And now list the factors of the leading coefficient, 1 and 6, 2 and 3. List the factors of the constant, 1 and 2. Then look at the signs, plus, plus. That's good. I like those ones because that means you're going to have parentheses plus a number, parentheses plus a number. But don't forget about who?
T.
T. T tags along the whole way. Okay, so now we actually have more choices for the first factor. So would you like to go 1 and 6, or would you like to go 2 and 3?
1 and
One and
6.
1 and 6? Okay, let's try it out. 1 and 6, that means I'm going to put a 1t here and a 6t there. And then the only choices for the n are 1 and 2. And how should I place those? Should I go 1 and 2 or 2 and 1?
1 and 2.
1 and 2? Okay, let's check. And we're only checking these ones. That t we don't have to worry about anymore, as long as we keep it along. So let's FOIL. I'll get 6t squared plus 2t plus 6t plus 2. This will give me 6t squared plus 8t plus 2. Does that look like that one?
No, sir.
No. So a quick fix is to swap the numbers. So let's try that. So I'm just going to flip them around. I'm going to say 2 and 1. And let's see if that works. 6t squared plus t plus 12t plus 2. I get 6t squared plus 13t plus 2. Does this look like that one?
No, sir.
Definitely not. So this means that which factors of 6 will not work?
1 and 6.
1 and 6, which means we move on to what other factors are left?
2 and 3.
2 and 3. Boom, 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 boom. So we know that that doesn't work. We've exhausted it. Now we go to 2 and 3. Whoops, I didn't erase that one. Boop. So I'll say 2t, 3t, and where should I place the 1 and 2?
2 and then
2 and then 1. Let's see. 6t squared plus 2t plus 6t plus 2. We get 6t squared plus 8t plus 2. Oh man, we're so close. Which means the quick fix is again to what?
Swap
switch. 2
Good.
and 1.
Switch them, swap them, flip them. Why not? So now 1 is going to go here. 2 is going to go there. And when we FOIL, we get 6t squared plus 4t plus 3t plus 2, giving me 6t squared plus 7t plus 2. Does that look like that one?
Yes, sir.
Oh, finally.
I have a question. So whenever it's like, because when we originally looked at it, it was 6t3 plus 7t to the second power. You just take you would just take, I'll just say x. You just take one x out and put it on the outside.
That's it.
All right.
Because the way we're factoring this only works for squared terms. It won't work for anything higher.
All right. Yes, sir. Thank you.
So yeah,
AC method works the same on.
AC method would work the same. You would still have to factor the T out.
Yeah. Cool.
Yeah. So you still have to factor the
Or-
T out, and then you would do 6 times 2, list the factors of 12, and go from there.
Or factor out however many variables there are.
Exactly.
Yeah. Okay.
Because in order to use educated guess or AC method, you still need to have the power of 2. You can't have anything higher or lower. Because we're factoring quadratics today, and quadratics means you're to a power of 2. Oh, good.
Yes, sir.
All right. 7. Again, have to rewrite it. 21w plus 6w squared minus 45. Rewrite it with the highest power first. 6w squared plus 21w minus 45. And we can list all the factors of 6, and we can list all the factors of 45. Or do you notice that there is a common factor between these 3 numbers?
3.
You can take a 3 out. Why not? It will make our work a lot simpler. So if I factor 3 out, that would leave me with 2w squared plus 7w minus 15. And now the trinomial inside is a lot easier to work with. Okay. Which means let's go ahead and list the factors of 2. 1 and 2. List the factors of 15. 1, 15, 3, and 5. And then look at the signs of your trinomial. Plus minus means we'll have plus minus. So we'll have something plus a number, something minus number. And don't forget about who?
3.
3. Okay. Well, this one's nice because there's only 2 factors, or 1 factor here, right? Well, 2 factors of 2, 1 and 2. So 1 listing, which means I can put a 1w here and a 2w there. Now, you make the educated guess and test. Do you want to go with 1 and 15, or do you want to go with 3 and 5? And another way to think of it is when you're choosing these factors, you want to see that when you multiply 1 and 2 by either of these, you want to see which one's going to get you to the middle term of 7w. So that's another way to look at it. You're like, which term could I use that can get me to 7? So what do you think that would be?
So then it would be
3 and 5.
2 and 5.
Good. Good. See, that's the way you want to think about it. So we're going to choose the factors 3 and 5. And just like you said, it would have to be 2 and 5 and
Make
then
the
1 and
7.
3, right?
Yeah, okay, cool.
So you would put the 5 here and the 3 there.
Okay.
And now, of course, we have to check our work. Check. And you would get 2w squared minus 3w plus 10w minus 15. We'd get 2w squared plus 7w minus 15. Does this look like this one?
Yes, sir.
Look at that. We got it. So you're just playing with numbers. You're playing with multiplications and everything. So you're multiplying them, you're adding them, you're subtracting them to the point where if you keep working at it, you can just look at it one day and you can be like, I know what that factors to without having to list anything out. But one day, right? All right. Any questions on that one? Oh, good old factoring. Okay, let's keep moving. All right. 8. Negative y cubed plus 6y to the fourth minus 2y squared. Again, I'm going to rewrite this with highest power first. So 6y to the fourth minus y cubed minus 2y squared. Now remember, the only way to factor it is if the highest power is 2. So right now, the highest power is 4. And whenever you see something like that, you should start looking for a greatest common factor. Is there a greatest common factor here?
Y squared.
Take a y squared out. And this will leave you with 6y squared minus y minus 2. Okay, which means the inside trinomial is in the perfect form because it's now raised to the power of 2. Okay.
Is
Now,
the,
go ahead.
I'm sorry,
No,
I'm
go ahead.
one of the late ones, but is there a reason why you switch the original over
Why
to
we-
the one that goes from like, highest to lowest?
So why we took this one and rewrote it?
Yeah.
Because, well, we're going to be factoring them. So it
Mhm.
only makes sense to put the polynomial into standard form. And standard form would be highest power to lowest power.
Gotcha. And then it goes
have,
like alphabetically too?
exactly.
If there were
It
to
could go
be more
alphabetically.
numbers?
Yeah.
Or I'm sorry, more letters? Okay.
Yes.
Thank you.
So, and we put it in that form so we know how we're actually going to factor this. So it's always good to rewrite it if you can and put the highest power to lowest power.
Gotcha. That makes sense. Okay. Thank you for answering
Mhm.
that. Sorry.
You're good. Good question. Okay, and you list the factors of 6. You list the factors of 2. Here you have minus minus, which means that's going to factor to something plus a number, something minus a number. And don't forget about who?
The square.
Y squared. Okay. And now, who do you want to go with? 1 and 6 or 2 and 3?
1 and 6.
Let's go 1 and 6. Okay. I'll have 1y here, 6y there. And then lucky for us, there's only factors of 1 and 2 there. So how do you want to place the 1 and the 2?
Let's see.
Should we go 1, 2 or 2, 1?
2, 1.
Go 2, 1. Okay. Let's check. 6y squared minus y plus 12y. Oof. That'll give me plus 11y minus 2. Does this look like that one?
Mm-mm.
No. All right. Well, one possible fix is to switch the numbers around, but do you guys think that'll work?
Nope.
No, right? Definitely not going to work. So do 1 and 6 and, well, does 1 and 6, is 1 and 6 going to work? There we go.
Nope.
No. So 1 and 6 is out, which means we'll try 2 and 3 now. Boom, boom, and then boom, boom. There we go. So we'll try 2 and 3 now. I'll say 2y, 3y, and let's try 1 and 2. Now let's check. 6y squared minus 4y plus 3y minus 2. I get 6y squared minus y minus 2. Does it look like that one? Yes, we're good. So we have our answer there. Okay. Any questions on that one? All right. 9. Negative 8a squared plus 12a plus 8. Okay, well, we hate that negative in front. Well, I definitely hate the negative in front. So we're going to factor a negative out. But is there another common factor other than the negative 1?
4.
4.
4. So we're going to take out a negative 4. And that's going to make positive 2a squared minus 3a minus 2. And now we just list the factors of 2, 1 and 2. Hey, look at that, 1 and 2. Minus minus means plus minus or minus plus. So just keep it as plus and minus. Bring down your negative 4. And all right, this one should be nice. You're going to have 1a and 2a. Now, how should I input the 1 and the 2? Should we go 1, 2 or 2, 1?
One, two.
1, 2. Let's see how this works out. So we check, and I'll get 2a squared minus 2a plus 2a minus 2. And this will leave me with 2a squared minus 2. Oh, man. Does that look like the one above?
Nope.
No. So again, one of the easiest fixes is to switch the numbers. So that's what we're going to do there. Oops. So now we're going to put 2 here and 1 there. And let's see how it works out. 2a squared minus a plus 4a minus 2. And we get 2a squared plus 3a minus 2. Oh my goodness, so close. What's wrong with this one?
Signs are flipped.
Good. So
wrong.
this is a positive 3a. What are we looking for?
Negative.
Negative 3a. So one more trick. If you can swap the numbers, then you can also swap, flip, switch the signs. So that's our last trick. So that's what we're going to do. Now we're going to make this minus, and we're going to make this plus. And let's see if that works out for us. 2a squared plus a minus 4a minus 2. And you get 2a squared minus 3a minus 2. Does this look like that one?
Yeah. I don't, you lost me at swapping signs.
So we have a couple tricks if things don't work out. As you saw the last trick, you can flip the numbers around.
Mhm.
So last time it was 1 and 2, right?
Mhm.
Another trick is instead of swapping the numbers, how about flip the signs around? So earlier, this was 2a minus 1, and that was a plus 2. So you can flip signs around, and you can flip the numbers around. Those are just small tricks to help us factor.
Okay. So like you had mentioned something about like, you know, like if it's what was it like you gave us like some kind of thing that explained
The
like if
sign.
it was like a minus and a minus would
Good,
be
so
a
the
plus
sign
and a
chart.
minus.
Hmm.
So when it comes to like a minus and a minus being a plus and a minus, those don't necessarily have to go in that order.
Nope. Because remember,
Okay.
so I made a sign chart last class, but also on the front of these notes, the sign chart's there again. So look at.
I'm trying to find those notes. I printed them out, but I don't think I printed that one.
Okay. But look at here. So here you have minus minus, right? So it can
Okay,
go
yeah,
either.
that's the one.
It can go either way, plus minus or minus plus. This is why we're able to switch the signs around to get what we need.
Oh, I didn't notice them. Okay, the or, and that or is only in certain situations. It looks like.
Exactly. It has to be minus minus or plus minus because they share the same parenthesis sets.
Gotcha. Okay. Thank you. That helps tremendously.
There you go. Yeah. So we're just basing it all off of the sign chart.
I was wondering if you could do a AC method for one of these more advanced ones.
Yeah. Which one would you like to see it on?
I guess 8's probably good.
Number 8?
Negatives and stuff, yeah.
Okay. So again, for AC method, you're still going to have to factor out that y squared. Doesn't matter. So for AC method, we're going to start with this form. Okay. So I'll rewrite the problem. It is 6y squared minus y minus 2. I'll just leave that y squared off for now. Okay. 6y squared minus y minus 2. Whoops. Now remember, with the AC method, we take A, which is 6, and multiply it by C, which is 2. You can have the sign in there or not. I don't put the negatives in there. So for AC method, we're just going to do 6 times 2. And this will give us 12. And now list all the factors of 12. 1 and 12, 2 and 6, 3 and 4. And now we ask ourselves, out of this list of factors, which ones added or subtracted together can give me -1?
3 and 4.
3 and 4. Good. So it's going to be 3 and 4. All right. So now by AC method, the way we write that, I'm going to split it up now, is we are going to say 6y squared, and I'm going to rewrite this one as -4y plus 3y. Because is -4y plus 3y, does that equal -1?
Yes, sir.
So there we go. We do the split. And now we have our 4-term polynomial, which we can factor by grouping. And from 6y squared minus 4y, what could I factor out of there?
2.
2. So I'm going to take a 2y out, which will leave me with 3y minus 2. And then from 3y minus 2, we see there's no common factors, so we're just going to take out
1.
the 1. And now these look the same. So we'll factor out the 3y minus 2 and what's left over?
2y plus 1.
2y plus 1. And don't forget, we took out a what?
y squared.
Y squared. What were you
If
going to
those-
say?
If those two didn't match, what would you
If
go
those two didn't match, then you might want to switch the 4y and the 3y around. Because then you can make it 6y squared plus 3y and negative 4y minus 2. See if that works out. But like I said, AC method is fail-safe, so it should always work. But let's say you do run into that kind of issue, just flip these numbers around.
or possibly flip the negative and positive, or
Yeah. Well, no, don't
No.
flip those around, because remember that it has to be negative 4y plus 3y to get to negative 1.
one? Okay.
You can't flip the signs around on that. You can only switch their places.
Sir,
Cool.
just speaking in terms of like doing a test or maybe like a worksheet or something, would that be the answer if we're taking something out? It would be y to the second power with the parentheses. There would be no reason for us to add it in, correct?
Oh yeah, no reason to distribute it back in unless my math lab wanted you to.
Okay.
But our answer, that y squared, would be outside the whole time. So, like I said, you guys choose. You can choose AC method or choose guess and test. Stick with one method though. Don't confuse yourself by trying to work both. Only stick with one. So AC method works, but again, this is where it still works, but this is where it could get crazy. Let's say you had like a polynomial that was 6x squared plus 2x plus 50. Oh, no, I'm not going to say 50. I'll say 50. And I'll put a 3 here so there's no common factor. Because you can be like, oh, you can take 2 out. No, I don't want to hear that. Okay. So let's say you come across something like this and you want to use AC method. Well, now you're going to have to do 6 times 50, which is 300. And now you have to list all the factors of 300 that could possibly make 3. Do you want to do that?
I guess
No.
not.
I would say if you get any AC factor that's greater than 100, go to guess and test. Unless you are happy listing all the factors of 300. I would not choose that. Okay.
I don't know if I understand the AC method, so I'm just going to leave it alone.
All good. Okay. And that is factoring using the guess and test method. Any questions on those pages? List your factors, know your signs, mix, match until you get it right. And it's all for your benefit. It gets you better at multiplying, adding, and subtracting in your head. Like I've been doing this for too many years, so I can just look at it and tell you the factors without having to write anything down on paper. But that takes time. Okay, cool. So now we come across another factoring method called factoring a difference of squares. So this is when you're given 2 perfect squares, and to factor them, well, let's go back to when we did the polynomial worksheet. So remember that we had a plus b times a minus b, and we FOILed it, and we came out with this product of a squared minus b squared. So now what we're going to start with is a squared minus b squared. And if it is 2 perfect squares, then a squared minus b squared will always factor to a plus b times a minus b. But they have to be 2 perfect squares. So let's go ahead and look at that. Okay. And here is something you could reference because you're like, I don't know my squares. Well, there you go. There's 1 squared all the way to 15 squared. So those are your perfect squares. Okay. So for the first one, y squared minus 25. So anytime you see a variable squared, x squared, y squared, z squared, whatever variable squared, it's always a perfect square no matter what. So here, y squared is a perfect square. That's covered. But then we come to 25. Is 25 a perfect square?
Yes, sir.
Yes. So this means that since this is a difference of two perfect squares, this will just factor to y plus 5, y minus 5, and that's it, guys. Can't get any better than that. But they have to be perfect squares. Any questions on that?
No, sir.
Okay, cool. Here, we'll
Does
do
it
another.
come out?
Oh,
I'm
go ahead.
sorry, I
No,
have a
go ahead.
question. Does it come out differently if you were to put y minus 5 and then y plus 5?
Nope, it can be written that way as well.
Same.
Very good. Very good question.
Okay,
Even if you write it as y minus 5, y plus 5, same exact answer.
same answer. Okay, cool means. Thank you.
Good question. Okay, like I said, let's do another easy one. So let's go to 4. We have a squared minus 64. A squared is a perfect square. Is 64 a perfect square?
Yes.
So what would this factor to?
A minus 8, a plus 8.
That's it. You're like, that's too simple. It sure is.
Does it get harder than that?
Well, these ones get a little, it doesn't get
Okay.
harder. These just get a little trickier
Little-
now.
Okay.
It's the same exact process. We're just looking for perfect squares. Okay. So for number 2, is 49 a perfect square?
Yes.
Is, yes. Is 4 a perfect square?
Yes.
Yes.
Yes. And definitely s squared is a perfect square. And t to the 4th is a perfect square. So this is going to factor to 7s minus 2t squared times 7s,
It's 2t squared.
and that's it.
Will there ever be a reason for us, basically, if it wasn't a perfect square, it wouldn't even be able to work, correct?
If it's not a perfect square, then maybe there's a greatest common factor we can take out to make it a perfect square. But if it's not a perfect square and we can't do anything, then we move on. We
feel like
tried.
Great.
So,
So
it just-
every
messed up right now.
exponent, like those little ones with the exponents, those included. So it's not just the big numbers that we're looking at. We're looking at.
Exactly. So I guess one way to
Okay,
put
that
it,
makes sense.
one way to put it, that if you're looking at your variables, if you want to
Mhm.
know if they're if you want to know if they're a perfect square, then their
Mhm.
degree, their power must be even.
That's a good way. Okay, gotcha.
So that's one way to look at it. So any even power would mean that it's in a form of a square.
Okay. Or like any number that's divisible by 2.
Not divisible by 2,
No,
but that you can take
but-
a square root of.
Okay, okay, okay,
So
okay.
that'd be
Gotcha.
something, yeah. Yeah.
Gotcha, gotcha. Thank you.
hmm Because 49 is definitely not divisible by 2.
Yeah, yeah, no.
So
I was
that's-
talking about the exponents.
Yeah. Oh, the exponent.
But
Yeah.
yeah.
Okay. The exponents. Yes. If you can divide the exponents by 2, then yeah, it'd be a perfect square. That's a good
Okay,
one.
okay.
Yeah, that's good.
Okay. Thank
Yeah.
you.
hmm Okay. So number 3. So we come across something that was just mentioned. What if they're not perfect squares? Well, we look for a greatest common factor then and see if we can fix it. So look at 18 and 2. What could you take out?
2.
A 2. And is there another greatest common factor?
Z.
Z. And if I factor out a 2z, what does that leave me with?
Nine W2
Minus.
minus
1.
1.
There you go.
Yeah.
And now, can we factor the inside more? Is 9 a perfect
Yes.
square?
Yes.
Yes. Is 1 a perfect square?
No.
You sure? 1 squared is?
One. Yeah.
So 1 is definitely
it
a
is.
perfect square. So what would this factor
Okay.
to then?
3 minus 1 or 3W minus 1.
3W minus 1, and
3W plus 1.
that's it.
Okay. Can you do more difficult ones like that?
Yeah, number 6
Okay.
looks like it.
Yeah, that
One
one
we-
looks ugly. Let's do that.
We'll do that one first. Sure. Sure. 98 and 50. Are those perfect squares?
No.
No. So let's look at 98 and 50. What's the biggest number you think we could factor from those? And if you don't know where to start, well, look at the numbers. Are they even?
So 2 works.
Good.
Can't.
Yeah, I see 2 only.
2.
I
So
thought it was
let's
gonna be
factor a
small,
2
but-
out, right? And is there another common factor here?
The N?
M,
And
M, and then
N,
an N. If I factor out a 2mn, what would that leave me with?
25.
No.
What was the first number?
Oh,
49.
49
oh,
m.
2
M squared minus 25.
There you go. And now, inside, are those perfect squares?
Yes,
Yes.
Yes. So what are we going to factor to then?
2M, 7M
7.
minus 5. 7M plus 5.
There you go. That's it. Okay. That means number 5 is going to be a piece of cake then. Is everything there a perfect square?
It is.
What's it
Yep.
going to factor to?
It's going to factor
5Q
5Q minus
minus 7W. And then 5Q plus 7W.
Q plus
There you
7.
go. Too easy, guys. And that's how you factor a difference of squares. Any questions on that?
Question on this paper.
Yes.
Is this one of the ones that you uploaded like as a blank copy like for the lecture?
Yeah. If you need it again, I can put
Yeah.
it in the chat real fast.
I'm on my phone right now because my
Oh,
computer's
so you
dead.
couldn't.
And
Okay.
lucky me, I didn't bring my cord. So my phone's probably gonna die while I'm on here. But I just want to make sure that I print it out. Which lecture would it be listed under?
It's
Because
under.
I feel like I printed every one but that. The last thing I have on here is like polynomial notes, and I feel like that's what we were doing. But
Yeah,
or
we
maybe
did
not.
polynomial notes at the beginning of class. Yes, the other day.
Yesterday?
And then, or 2 days
Okay.
ago, whatever. On
Yeah.
Tuesday. And then you can find these notes under factoring rules in that module. It'll say factoring
Factoring
rules,
rules.
lecture, factoring strategies.
Okay. Thanks for that. I appreciate it.
Mhm. All right, guys, last page. So we saw a difference of squares is factorable. And now if you ever come across a sum of squares, a squared plus b squared, then this is not factorable at all. But if it has the greatest common factor, let's go ahead and take it out. But all we have to know here is that a sum of squares is not factorable. So let's go ahead and try these last 4 out and look at number 1, p squared minus 9. Is that a difference or a sum?
Difference.
Difference.
Which means we can factor it. So what would p squared minus 9 factor to?
P
P
minus
plus 3.
3, P plus 3.
There you go. P minus, P plus, whichever. However you want to write it. That's done. 2. p squared plus 9. Is that a sum or a difference?
Sum.
Sum. Not factorable. But since factorable is not really a word, we can also call anything that's not factorable, you can call it prime. Because it's just not factorable. Okay. T squared minus 144. Sum or difference?
Difference.
Difference. Are those two perfect squares?
They are.
What would it factor to?
12.
And t plus 12. All right, last one. T squared plus 144. Sum or difference?
Sum.
Sum. So
Prime.
prime. That's it, guys. And that
Don't hate
is
me.
factoring.
Well, don't
Go
hate
ahead.
me.
Go ahead. What?
Can you tell me? Okay, so I caught one, but then my phone kicked me out, and then I came back in, and you were saying not factorable prime. Is that's because of the plus sign and
Exactly.
the fact that they're both what's that
So
term
they're
you're
both
using?
perfect squares.
Perfect squares.
So
Okay.
so the sum of two perfect squares is
Uh-huh.
never factorable. So we call it prime.
Gotcha. Okay, I got it. No, I guess it's because the P threw me off, and I'm not seeing like the A and the V.
Gotcha.
Okay, got it. Got it. Thank you.
So is there no way to factor those?
Oh, you can, but you'll never learn it unless you switch your major.
Okay. Sounds good.
What major is that?
Oh, just
I'm going into finance.
right. Just a science or math, science, engineering, mathematics major. 'Cause
Okay.
we can actually
Yeah.
factor them, but we're going to get imaginary values. But since you guys are business majors, nobody wants to see imaginary values in your business.
I won't see that in financing.
No, we hope not.
Yes.
So yeah, well, trust me, everything is factorable, but for our sake and this class, this is not factorable.
Okay, I'll take it.
There you go. Okay, guys, this is a great stopping point. I don't want to jump into anything else. So we are done for the day. So if you got questions, hang around. If not, see you on Tuesday.
Sir, tomorrow's our last day to finish the test, correct?